Meetup. Nice to see all of you here. My name is Erno Kurki. I'm one of the hosts from the CNCF and the Cloud Native Finland side. Then we have Gerson here. Who else from the CNCF Helsinki? I guess not any more people today. I think everyone is still exhausted from KubeCon US. Our agenda today, thanks for hosting us, Supermetrics. Oscar from Supermetrics is gonna go next and talk about the never-ending, always-on journey to Kubernetes, improving our routing with Kuntur and other CNCF-related tales. Then we are going to have application isolation network security insights in Kubernetes by Jose. You know, even though I checked these slides like 100 times, but after some time you become blind, so I kind of mixed the topics here. And then we will have Toni talk about using AKS to enable developer experience and regulatory compliance. So, thank you guys. Cloud Native Nordics. Who's new here? Who's like here for the first time? Okay, so we still have a couple of folks. Cloud Native Nordics is spread across the Nordics, of course. We have a couple of chapters here in Finland and, you know, Helsinki, Turku and Tampere, and Toni here is representing the Tampere chapter. Then, of course, also across the other Nordics, and not, of course, forgetting Iceland either. Welcome new members. So I checked at 3 o'clock today and we had 1,994 members. So if there are a couple of new people here joining, then we might be like 2,000, but almost there. So let's have a party when we reach 2,000 members. And still growing. We follow the CNCF Linux Foundation Code of Conduct, but basically be nice to everyone and include everybody. We are always looking for speakers. So if you have some topic you would like to talk about, then please reach out to me or Gerson here or via some of the channels here to propose a talk. And that also applies to hosts. So if your employer or if you yourself want to host a CNCF meetup, you'd be very welcome to do so. So we skipped basically the October meetup, but that doesn't mean that we have not been busy. Because what we essentially did is that we founded a Cloud Native Finland non-profit organization in order to facilitate all of these meetups and, you know, promote cloud native technologies and sharing knowledge, creating space for technologists to share their experience and ideas. So at the moment we are basically the core like founding members there, and we still need to kind of, you know, put some practicalities into place, and then we open up the organization so other people can also apply as a member and also accepting companies as members, because the idea is really to have a common good for doing all these meetups and kind of have a better basis for organizing things, maybe even, you know, getting folks from abroad to talk into these meetups, how to kind of reimburse those, and so, you know, just to guarantee that top-notch content also in the future. And kind of the initial idea why we had to have the organization is to have the physical entity, because we are planning to do, or not planning, we are going to do a Kubernetes Community Days conference in May 2025. So more information to follow regarding that also very soon. So what is CNCF? Almost 10 years old organization that hosts all these projects and the technologies around the cloud native computing technologies. We often talk about the CNCF landscape. So the landscape consists of graduated products, which are safe to run in production, then incubating products, which are also safe, but not like exactly graduated. So they are just, technically safe, but missing some aspects like how the community is managed and, for example, documentation. So examples, incubating products. And then there's the sandbox projects, which are kind of new projects added into the landscape. Something that, everyone here is very safe to contribute to. Otherwise, CNCF structure, so it's an organization. So the main entities is the governing board, technical oversight community, and of course the end user community. And basically the governing board is mainly the bigger vendors who fund the organization. Then there's technical oversight committee. So actually 11 architects who are chosen so that they are well-known personalities in the tech community, and they have the talent and also can dedicate the time to oversee the technology projects. And then of course the end user community, so everyone here also who contributes somehow to the organization. Something else about the org is that CNCF provides a lot of trainings revolving really around the technologies around Kubernetes and the different aspects of Kubernetes, so administration, development, security, and different levels of these certifications. And if you do them all, you can get this Kubestronaut nomination and a nice jacket. So here's a larger list of the trainings available. Gathering with the community. So yes, we are doing the KCD here in Helsinki, but then there's also, they announce all the KCDs worldwide. So there's going to be a lot of events around the Nordics, around the world. Then other meetups in the Nordics, and of course lots of different type of programs that the CNCF facilitates. The next bigger event is going to be the KubeCon and Cloud Native Con in London 2025, so April 1st to 4th. And one thing came to my mind that England, so UK is starting to require ETAs for those people who don't need visas. So keep this in mind if you're gonna go to KubeCon London. So the electronic travel authorization, same thing that they have in US. So also EU citizens need this, I think, starting from April. Yeah. The ways to reach out to us, different kind of channels. And also this event is being streamed. So if you want to go back to some of their presentations, you can find this on YouTube. So thank you. That's on my part. And let's give the stage to Oscar.
I hope this is not now too too loud for people.
If you're close by, you can also read it on the table.
Okay, I'm gonna be around here so it's easier. Anyway, hello everyone and welcome. It's great to see some faces that I know from different places that I haven't seen in a while. And it's also great to have everyone come to Supermetrics today. I'll introduce myself, but yes, I'm not going to read again the long title that I thought about sharing with you today. As you see, it's not very focused, but hopefully there'll be some interesting conversation that will come out of this talk. But before we move there, as I said, welcome to Supermetrics. And the reason why it's interesting for me to welcome you here today is something that I'm going to talk about in a moment. But before, let me just at least introduce myself and who will I invite a little later on the talk. So I'm Oscar Craviotto. I was born in Argentina, Italian family. I think Barcelona is second home. I've been living in Finland for about 13 years. So yes, I have a little bit of an identity problem. But I have been working with Supermetrics for 7 months now. And the details, well, almost 8. I'll reveal in a moment. As I said, I will not be alone. I'll have Craig come over to help me with part of the presentation. He's actually just come from Canada, unfortunately not just for this event, but we wanted to, well, say that he had actually come for this. He's been a little longer with Supermetrics, and he'll talk more about what he's been working on specifically in the last few weeks or months. So the empty slide. The reason why I was talking a little bit earlier about a specific time in Supermetrics for me is because about a year ago, I was sitting right there where you are, also visiting from another company, and participating on the CNCF meetup here in Helsinki. I didn't think at that time that I was going to be joining this company, but I was impressed by the office. I wanted to actually have a picture here with a beautiful view of sunny Helsinki. Of course, I don't have that today. I tried one in the earlier part of the day. It didn't really come sunny. I guess you know why. But I did still find the office very cozy and homey, and made me feel that, oh, maybe this is not such a bad place to work after all. And after 8 months working with the company, I can tell you it's not a bad place to work. Not that I want to talk about hiring, but we are hiring, right? So this is so there are a few positions there. Just if anyone is interested, we just published these two. There is still one lead security engineer that we're going to open tomorrow, Friday. If you're interested, you can take a phone. I'll pretend I'm not looking, and you can then. Otherwise, you can visit our page later or talk to any one of us or my colleagues who are also here from Supermetrics. Some of them actually have Supermetrics t-shirts. If not, obviously Craig, and I see Jan David over there. I see also Pavel, and then Alexei is also there. So just talk to one of us, and we'll be happy to connect you and be very honest about what it's like to work here in Supermetrics. But in case you're still wondering about Supermetrics, so let me tell you a little bit of story. That is going to help us also set the conversation and the tech talk later on. So what is Supermetrics? How many of you actually know what Supermetrics does? If you raise, yeah, thank you for the people working here. It's good that you know. And what we do, that's encouraging. But basically, Supermetrics is a platform for marketeers. Most of our customers are either agencies or brands, and most of our people working with our platform are people working with marketing data. So what do they want to do with our platform? They want to connect to get the data. They want to manage that data. There are a lot of different sources with different fields, with different types of fields, and they want to make sure that they connect all the different dots in their data to understand their data. They also want to analyze the data and get insights from the data. And also, of course, in the last point, they also want to activate. That is, they want to make decisions based on that data. In a nutshell, our platform does a little bit of this, right? It just helps customers go fetch data from multiple different types of data sources. Then here on our platform, they can actually connect, manage, analyze, and activate the data. And finally, then do with that data something. In some cases, that's putting the data back into some of the platforms that would enable them to make the best use of that data, or just keep it in Supermetrics and use Supermetrics also as an API to further treat that data or make that data visible. So that's basically the product, the platform, the SaaS that we actually operate, some of the details of which we're going to be discussing during this talk. So to provide a little bit more context in the end, we do have some interesting customers. There are about 270,000 companies that rely on Supermetrics to process their data. And we estimate that about 15% of all the global ad spend is reported through Supermetrics. By the way, that's the ring, just in case you're wondering what's going on now. So it doesn't mean that that is exact amount of revenue that we have. That's not the case. I wish it was. But it is about the percentage of the global spend that is reported through Supermetrics. So this is hopefully a good view on what is Supermetrics. And of course, we're here. If you have any questions later, you can ask us. So what else can we tell you about Supermetrics? Well, this is one of the tells. Okay, so the talk was about tells. And one of my favorite metaphors when it comes to describing what we do and what a platform looks like is to talk about European cities. So bear with me as I try to make the connection, okay? So you're still wondering, especially as I show you this picture, that I make a little bigger. Anyone, any idea what city this is? Somebody said Barcelona, yes. Right, that's Montjuic. And so this is Barcelona around 1850. Beautiful place, all within the city walls. There were city walls back then. They were destroyed around that time because they were growing. The density of population Barcelona had was about double Paris. So it was growing and growing and growing. By the way, a lot of these things are still there for those who have visited Barcelona. Those trees over there, that's Ramblas. Okay, so that's still there. So why am I talking about European city and Supermetrics? Because Supermetrics is about, 10, 11 years old as a platform. And as many SaaS platforms, it grew from humble beginnings, maybe a church, maybe a square or marketplace, and then organically gets expanded into additional functionality, just like all towns grow. Eventually, if you visit, and this is what tourists do, right? You can explore and admire the beauty of it. Just like if you were to look at the infrastructure, the components that make our application, in many cases, as a tourist, you would actually really value the beauty of it. Like, I'm sure you have never seen this in your own work or past experiences. If you really haven't, you're very lucky. But this is common. So, and this is wonderful. Except when you're not a tourist. Imagine how you need to drive through, especially if you're in a hurry. Imagine you're an ambulance, or imagine you're a big truck. Making it through those small streets is complicated. That's why the planners, at one point in the history of Barcelona, decided to actually expand, just like we also do with our solutions, right? At some point, we start realizing that what we built is not fit for purpose, and we decide that we need to actually re-architect and increment and expand on a plan. So this is a famous area of Barcelona outside of the old town that is called Eixample. In the Catalan, that means the extension. So that's how the planners thought about extending that, so that there is actually space for people to navigate through, to go fast, big tracks, and even park, because the Eixample has octagonal diagrams for the blocks, which enables a very big space in between these blocks. So this is actually the plan of that expansion. The black has the old town, what was there, just what I showed you in the beginning. And this is the expansion that actually took place. And what is interesting is that, just like with cities, also companies and platforms many times focus on the expansion, because it is much easier to plan a new terrain. There were only fields around the city. It was much easier to start from scratch. Right? We all know that. It's a lot easier to start from scratch than to actually have to refactor or re-architect existing solutions. But the planner in this case, Serdar, had actually in mind additional ways to at least help a little bit the work in the old town. So this is just the same idea that the original planner had, Serdar, in about the middle of the 800s. But later. In fact, this was actually discussed late 19th century, beginning of the 20th. Finally, there was work done on one of them. This is the only avenue that is currently traversing the old town in Barcelona, called Via Laietana. And this is what it looks like. So this is that line there. That's the only one that they got to build. You can see very clearly the difference. Just like if you look at the architecture of many of the components of Supermetrics or many of the other companies. And this is what happens when you need to actually open the Y in what exists. It's a mess. So when you have to refactor and do a lot of the changes in the actual places where people live, just like when you need to refactor your solutions, that's where the mess happens. Of course, the planners were actually pretty smart, and they decided to actually build the metro at the same time. But this looks like somebody bombed the city just to make a street. Well, it doesn't look a lot more beautiful if you look at some of the changes we're doing in our code and some of the changes that we're going to be talking about in a moment. So hopefully everyone now is in this tale of a European city, beautiful. We're going now to move a little more on the actual technical conversation. This is just what our solution already was on version 2. Okay, so this is already a little more complex, but already at this point we are on AWS. The company has always been on AWS. It started on the cloud. The main mechanism for serving requests is using CloudFront. And this, you can see, has already 2 different types of deployments, depending on whether it is what we call internally the main line or the regular platform, and then the enterprise version that is actually catering for a particular type of customers. So, as with the plan, we also expanded. Though we expanded on top of what was there. We're not going to go into all the details of this network connectivity, but mainly the new things are, for example, we expanded into GCP. And not only on 1 region, but also on 2. So we also opened a region in the US to serve better our customers in the US. We put a lot of the logic, and we're going to be talking later about that, of the routing on Cloudflare. Remember, we were using CloudFront, but now we moved into Cloudflare, and Cloudflare has more and more of that logic to a point that is becoming to be also painful. And Craig will talk about that pain later. And we started with an initial Kubernetes adoption, and I will talk in a moment about that too. And this is actually represented by a little square here and here. So this is another similar drawing, a little newer, but it's again another abstraction, and it's simply just to show again where AWS and Google Cloud are expanding and more committed to Google Cloud. We have Cloudflare. We're now beginning to use EKS and Cheeky, and in Cloudflare we do a lot of things as well. So this is just to give a high-level overview of that. So partners, I already mentioned AWS. That's where we started. Another partner in helping us manage a lot of the databases that we have is Ivan. We will talk a little more about that too, but Ivan has basically simplified dealing with complex setups on databases across clouds. We also use Redis Enterprise, and the funny thing is that actually that forced us to get acquainted with Kubernetes before we did Kubernetes anywhere else. Another one we already mentioned, Cloudflare, for anything related to edge and a lot of logic for our routing. The reason why this is big is not because Erna is here. It's also because Google has become a more and more important partner for us technically, and this simply represents that space. And we also have another enterprise partner in Datadog, though as this is a topic for discussion another time, it's becoming more and more painful cost-wise. So we are all looking for alternatives, I guess. If you have any hints, we are looking for ways to move some of that. Anyway, so this is just to give you a big picture on what we do. So the journey to Kubernetes and to other CNCF projects. It's a moving target. You know the pain, right? And it's not just a pain. So CNCF, right? Do you know this site? It has the address here, the devstat.cncf.io. If you add the prefix K8S, practicalities.devstats.cncf.io, you will get a graph and a dashboard with data on Kubernetes, on the repository. So this is just one of the dashboards. And all I did was I wanted to see by month since 2014, so the beginning of the Kubernetes Git repo, how many PRs have been merged, okay, to get an idea. So it is very small here, so you might not see it, but do you know how many PRs, not lines of code or number of commits, but how many PRs have been merged? Again, not opened, but merged. Since then, it says 55.4 thousand. So 55,000 PRs have been merged. The red lines here are the releases of Kubernetes. So you can see how before version 1, they were coming almost very close to each other. Then we had a 4 times a year cadence, and we went to 3 years cadence, and anyway, you can see. Regardless, that's a lot of change constantly happening. Okay, so I guess you're all there with me. This is the metrics page at the CNCF as well. This is the number of projects. Erno was presenting earlier a little bit of data on that, was showing some of the logos that make up the CNCF series of projects. If you look at this and you hover over the graph, which is actually fed from data that is actually coming from that dev stats, you would see also that there is a series of things that happen. This is, I wanted just to make a comparison. I wanted to look 2 years back and then, okay, there were 87 sandbox, 36 incubating, and 19 graduate projects back then. And then I wanted to look at now, so just a couple of days ago, 130, so we went from 87 to 130, incubating stayed stable, and then we went from 19 to 29, and a few more archived. So all these means that in terms of Kubernetes changes and CNCF projects, it is hard to think anyone could slow down and still keep on the same train, right? Over 5,800 PRs merged, 35% increase in sandbox and graduate projects, and that's only in the last 2 years. If you are like me and every now and then go check out the landscape of the CNCF, you would always probably see, oh, I never saw this one. When did that happen? And you go and start looking at projects, and then it's amazing the amount of things that keep coming up. So in a sense, and because I know you also know that feeling, it is like this, right? That's, if you stay and you don't move, you actually go back. It's a constant effort to keep, to support Kubernetes or to keep up with any of this. That's other people who are more clever than me have been talking about entropy, right? That sort of dynamic that is, it means that you need to just make an effort to keep up with things. So anyway, I love this. I just remember this and I thought it was a great way to represent my feeling many times. And I am looking at one guy that I used to work with that used to do Kubernetes upgrades. And we were always talking about, hey, did you finish the upgrade? Yeah, oh, you know what? There's a new version now. So this is where the naming convention and the idea of sandbox, incubating, and graduate comes from in the CNCF. This is also on the page, and this is about adoption. So when we're talking about what it means basically how wide is the adoption. And the reason why I wanted to show this is not only because I'm sure many of you know this, but may be useful to some. And also it's also interesting because it's based on Crossing the Chasm, which is a very interesting book from about 20 years ago. But also because I wanted to show where we are as a company. When you look at this, you might find yourself in different places. So I promise honesty. So this is where, so I see Supermetrics. The truth is, we are a little bit conservatives here in the company. There is a reason for that. We have a business to run. We have a lot of customers. So we need to be conservative. But there is another reason. And this is represented by the type of projects that we adopt. So if you look at our core stack when it comes to the CNCF, if you notice, one particular thing is that none of these are sandbox projects. In fact, only Contour is incubating. Argo, Helm, Kubernetes, and a few other things like Server Manager, they're all graduate projects. That means we are pretty much aligned with that model in the large majority. So let me just give you a few additional ideas as to how we use these different things. So how do we use Kubernetes? Well, we first said that we use AWS and GCP. So we use EKS and GKE. At the moment, there is no self-managed Kubernetes clusters. And what can I tell you about our Kubernetes stack? Well, it's mainly Terraform managed. We use also TerraGrant. We do have a few clusters, about 15 if we count staging and production. And we use them for different things. I already mentioned Redis, and I told that that's how we got started with Kubernetes. We use Redis Enterprise deployed on exclusive clusters that are only used for that. We obviously run some of our components for our SaaS platform on Kubernetes. We use Kubernetes for internal tools. And we also use Kubernetes for our products analytics stack. We deploy in multiple regions. I already explained that we have mainly the US and Europe. In Europe, we have Belgium for GCP and Ireland for AWS. We use Virginia and GCP in the US. And in any of these regions, we do have Kubernetes clusters. And how do we expose or connect to these clusters? Well, we use, and we'll talk a little more in a moment, Cloudflare D. We don't expose this other than through Cloudflare when it comes to anything that runs on these clusters. Helm is mainly used with Helm file or with Argo CD. It is, again, either used for internal components, like the typical components you install in a cluster, or CRDs. It is also used to manage databases, either directly or deploying operators, or deploying components that are managed by operators that manage databases, either on Kubernetes or outside. So we talk about Redis, Trino, ClickHouse, Ivan Operator, Google Config Connector. And of course, we use it for Supermetrics applications. As you know, one of the main reasons for anyone to use Helm is because it simplifies the developer surface. It just allows us to abstract away some of the details that would otherwise be exposed if we were using something like Customize or Manifest. I know that there are many other tools nowadays, but I won't go there. We are conservatives, so we use Helm. Argo, what do we use from Argo? Both Argo CD and Argo Rollout. Of course, we don't use Argo CD for everything. The company has started adopting GitOps about a year or so ago, well, a little over. And so we are expanding what we are using Argo CD with. The things that we use Argo CD with are anyway managed in a single cluster, which is a pattern. You know that you can use GitOps in multiple patterns. One of the most common patterns is a single cluster. In other life, I preferred always to have a cluster with an Argo CD per cluster, but we have a single cluster. And Argo CD applications are managed manually, are managed in a single repo that has them all. And then once created, they follow the recommendation of a single branch, master, and follow master for our users to be able to manage their own components directly. What else could I say? Well, GitOps is used, for example, with some of the Ivan databases, as well as GCP resources. And rollouts is actually not widely used. It's only used with a subset of components, mainly migrated from VMs, and enabling us scaling up and down, etc. And finally, we're getting to then the last topic, and for which I'm going to invite Craig. So we're going to have a little bit of a conversation with Craig, who came all the way from Canada just for this. Yes. Yeah. So Craig, we're looking at Contour and simplifying Cloudflare. Can you tell us why did we decide to do that?
Yeah, so a little bit backstory. I mean, we've had, as we moved the logic into Cloudflare, we have multiple clusters, as Oscar mentioned, and a lot of that logic is in Cloudflare on incoming client connectivity going to one of our 3 clusters, but also the concept of a primary cluster for some things are singleton, shared authentication, licensing, stuff like that. And as we're moving from what we'll call legacy VMs into many microservices in Kubernetes, having that logic in Cloudflare and also in Kubernetes just didn't make sense. So we started with the first or second microservice, having that logic in 2 places, and that second place is really 3 clusters, and as we grow it's going to be 5 clusters, 20 clusters in different regions, and maintaining that just wasn't going to work out. So we're looking at moving, or we're in the process now of moving that logic. Which cluster to go to will be in Cloudflare, and then which service to go to will be in the cluster itself. So Contour is what we've chosen to do the gateway API routing, and we'll go into some examples of the actual manifests and sort of actual talk-through examples, but really most of our traffic right now is still going through VMs. It's being serviced by VMs. It's going to be serviced by Kubernetes services, endpoint by endpoint, and new applications will go there. But we need to get a way to go to VMs and get rid of the logic in Cloudflare. So we're going to start routing all the traffic through our Kubernetes clusters and through Contour, and any backing traffic that needs to go to VMs yet will then egress via an HA proxy to the VMs that right now they're going. You can just sort of hide this in the middle. Just go back.
Okay.
Yep, if you hide it in the middle. Right now the traffic is going directly to the VMs. It'll be routing through the Kubernetes clusters, and the default rules will just go to VM unless there's an overlaying rule to match it and send it to a Kubernetes service.
So, okay, that's good. That's why we're doing it. But maybe another good question is here. You mentioned Contour. Why did we choose one Contour, but in particular, why did we choose to go with Gateway API?
Yeah, so for people who are maybe not familiar with Contour, Contour has been around for quite a while, and they offer a proxy service of their own called HTTP Proxy, which has a lot of, it's under the hood, a little bit of background. Contour for the data plane uses the Envoy proxy, and they overlay a bunch of management on top of that for their HTTP proxy named rules. And when Contour is now at their current version from July 1.30, they introduced Gateway API support that is matching the Gateway API 1.1, which is the first GA release of HTTP route and TLS route. And so the main reason that we chose, instead of the more, let's say, mature Contour HTTP proxy, but to go with Gateway API, was the ease of enabling the developers to sort of control their own destiny. Be able to actually, it's built in Gateway API, the infrastructure, the operations team, or the SRE team to build the platform and let the application developers create their own rules and routing and manage their entire service themselves completely. So HTTP proxy allows a little bit of delegation, but it is not at the maturity level that now exists within Gateway API. Just go back one more. So to be clear, today we're going to be talking about HTTP route and a bunch more stuff. TLS route, or also a Gateway API gRPC route, and TCP or UDP route are still available, and they're in experimental preview so far, so maybe we're not ready for them ourselves, but they're there, at least usable, and will give us more options when we decide to take them on.
So you also asked me to have this to have a conversation too about what is that model. How do you see our teams using the different entities that are now made available through Contour and Gateway API?
Yeah, so right now I mentioned that we have some default routes. So if we look at, actually what the operations team is controlling is right now just a list of, we'll show them later, but a list of about 6 different rules that are matching the logic going to the VMs. And then as a developer wants to, port something from the monolith that we're running on the VMs into a microservice, they can get it working and test it, obviously, and then they just have to insert a route that matches path, headers, query string, combination of all those, and route it to their service. Already with Argo that Oscar was mentioning, we are using a canary-based deployment. So as soon as the deployment goes out, a certain small percentage goes to the new version, and as it's functioning, starting up, getting 200 results, more and more stuff goes to it, and so Argo is controlling that right now, and Argo will be controlling the HTTP route backend weightings as we move to Contour. What's not on this lovely diagram that I stole from the Gateway API website is a third, which we will have. So when a developer's moving stuff from the VMs to their brand new shiny Kubernetes service, we will have a third backend, which will be the VM that will start at 100% and move their deployment, let them move their deployment into a certain amount of percentage to not just, okay, we're going to Kubernetes now, but actually give them their own control of how much do they want to move into their new service and be able to back out and have that all managed automatically.
One interesting aspect of this we already mentioned is that we actually connect to our clusters only through Cloudflare D. How do we actually tell Cloudflare D where is the traffic routed to? At the moment, we're also using Nginx ingress on our clusters, and so how are we going to change that? And I think we have some
I think we have
config here.
Some config on the Cloudflare D.
So Cloudflare, that's supposed to be Cloudflare. That's my type.
No, that's right. This is the spec. That shouldn't have a D in the beginning there,
Oh, yeah.
I believe.
Okay, but it says control.
Oh, yes, that's over here. Sorry, I just...
The color is right, but
yeah. So right now, our traffic is coming through Cloudflare to the VMs, and there's no tunnel going to the VMs. It's just, pick your cloud provider load balancer. When it's going to Kubernetes, we have the Cloudflare D tunnels, and we're going to have 2 tunnels, which we'll talk. This is talking about the blue. We're deploying everything blue-green so that we can. I'll go back. I missed an analogy that I was going to talk about before, but we're doing a bunch of this transition and stuff, and we are all the stuff we're building is to be able to do any changes to anything in the middle of the day while our customers are using our product. So we're going to be changing the flow and moving stuff from VMs to Kubernetes and back and forth and whatever anytime. So that was a real, early on heavy requirement that, downtime isn't an option. And so having a blue-green system right the way through from Cloudflare all the way through is really important. So I think most of the examples you're going to see is blue, but we'll have everything you can assume. We have double in blue and green. But back to the onboarding from Cloudflare, using the Cloudflare load balancer, we have multiple pools that will have multiple backends. So right now the backend has VMs backend origin and two tunnels, and we can control the weighting back and forth between them, and we'll be using that to control traffic coming into blue and green tunnels. And like Oscar mentioned, these are not, obviously they're on the internet, these clusters, but the only access to them is via the Cloudflare D tunnel, which is the Cloudflare D binaries run on the cluster and connect out to Cloudflare. So there's no public ingress into any of our clusters.
Yeah, and then we have a few examples of configuration. I don't know if you simply want to remind people what are the main resources that are managed when it comes to Contour.
Yeah, so Contour, so we're coming in from Cloudflare to Cloudflare D, which is a separate product, and then the ingress, which, the legacy ingress, let's call it, would be Nginx ingress. That gets replaced in the Contour realm with a concept called a gateway, which is really a gateway API resource. But Contour configures and manages it completely. And again, it's blue here, so we have two different gateways. Go to the next. This is, well, actually, sorry, I was looking for the listener.
Yeah, here.
Yeah, so the listener in this case, you can attach and have multiple gateways and have a gateway listen to specific host names. In this case, we're deploying just one plus one equals one gateway, blue and green, to listen to all traffic basically. This is maybe not exactly what we're running. Use your research. This is a good stock example, but your mileage may vary on the exact data that you see on the screen. So go on. Let's see. So from the gateway gets attached so I guess under the hood in the gateway, Contour deploys a management plane called Contour, and a data plane, which is the Envoy proxy, which they've customized a little bit, but it's really a similar Envoy proxy you can just deploy from Envoy. The routing logic provided by or supported by Contour is provided by the gateway API spec called HTTP route, which lets you attach a host name, and it can be some wildcards are allowed in the subdomain, but they're full subdomains, subdomain wildcards. You can attach virtually unlimited number of routes to a gateway, and we're actually attaching, as you can see, the route to both gateways, so that we don't have to duplicate the routes. And then this is an example of our default. So basically, the path prefix is slash, and it's just going to our HA proxy. And from there, then HA proxy has a bunch of different backends that are identified that it goes to the right place, to the VMs. But this basically, from say like this block, is what a developer would control to match. And I don't think this example has any headers or any query parameters. No, it doesn't. But there can be a multitude of matches to control where the traffic's going, what service output you want to go to. We're going to we have already, and we have some more plans to do some more, is to give the developers a simple chart to consume that will be hide a lot of what they need to do to just make their lives easier, A, and B, make sure that some of the parameters that need to be correct are correct, and that sort of hide some of the typos from them, and YAML spacing, and some of this fun stuff that we're all living with. Another thing that Gateway API has mandated, so by default there's no cross namespace traffic allowed. So there's a reference grant that basically can allow a source namespace and a destination service and namespace that you don't specify the namespace, but it's in where it's inserted as the destination namespace, just to allow traffic in a sort of from to. and that way you can, again, delegating the control to certain, sort of end user namespaces without worrying about too much, cross namespace security.
All right, excellent. Thank you, Craig. And so now we arrive to the moment in which you also get to ask questions. And so, yeah.
Yeah, first question, maybe a little bit silly, but why you have one white space indentation in all YAML?
This is actually something that I pasted. No. This is not a picture of an actual YAML from our repo. Just for reference, I can show you that this is all text on the slide. So I simply
understand it's sometimes missing, but yeah, sorry. And the second question is, as far as if I understand correctly, you have a load balancer actually in the cloud, and then it's going to the cluster, right?
So the load balancer would be in this case the Cloudflare load balancer,
Okay.
not the cloud, not an ALB or not yet. So for the VMs, yes, we had our legacy VMs are running a either application load balancer or depending on like on Amazon. But for the Kubernetes clusters, the load balancer is the Cloudflare construct that is sort of
Okay, and you said that you forwarding traffic to these VMs via HA proxy.
Yeah.
Why not using, for example, external service in the Kubernetes?
Yeah, it's very good. So we tried.
Okay.
Gateway API forbids it for the security reason, because you could, if you're using that as a backend, you could target another namespace as a backend to that, and so it's a security risk.
Okay.
So
that was the first thing we tried.
yeah. So in the HTTP proxy, so Contour's HTTP proxy actually allows it after you read through their disclaimer trying to discourage you to use it, but you can't override it. Gateway API forbids it outright. There's no override.
Well, it's nice to know.
Yeah, so we are using HA proxy, which then, I mean, of course we can override it, but we're deploying it in the private namespace, hence the reference grant to get to it.
Okay. Yeah, thanks.
Yeah, for sure. That's a good question.
Thank you for the story about your evolution throughout the years. So, how do you at Supermetrics allow developers and yourself to focus on the maintenance needed to make sure that you are not status quo in updating versions, and so with all these feature requests coming in, operations wanted to make sure that it's stable and nice, but still making sure that you're up to date with new.
I love the assumption that we actually do keep everything and up to speed. There are different parts to that question, if I understood correctly. You correct me if I have misunderstood you, but there is, on the one hand, there is the recognition of what we call, generally speaking, technical debt. There is a very good case to call that differently than more organizational debt. There are many reasons why we accumulate, but if we just focus on the things that are part of our responsibility, it is not always easy to focus because I guess, well, I don't want to offend any product manager here, but there is always, unless there is a close alignment between every member of a product organization, it is always difficult to find the right amount of dedication to creating the features and the reasons that our users want to buy us versus the other things that are more invisible to our customers, but the ones that when they break, everyone notices, from security to also reliability, etc. So we do have a constant backlog of technical debt items that we need to address, but I'm not going to lie and say, yes, we succeeded. We have now, for example, planning next year. We have a whole list of items that we want to really make sure and prioritize on a roadmap to make sure that that doesn't happen.
Prioritizing into the roadmap is how you are handling these things.
Yes, that would be a good summary. Thank you. That's better than ChatGPT. Yes.
Yeah, we do struggle with it for sure. But since you mentioned updates and stuff, Dependable helps a bit, like as a practical tool.
Yeah. Yes.
Yeah, one more question. So, Contour is on the market, if I can say it like this, a few years already, since like 2015 maybe even. It's
Something.
No. Okay.
No, I think I started
It's
using
5
it in
years
19.
or so.
Yeah.
Yeah, I think it's 5 years or so.
Yes.
Recently, I think Envoy started to build the Envoy gateway solution. So it's the control plane with Envoy as a data plane. Have you have opportunity to check it out and say something about this?
Not individually, I don't really have, I would say, the maturity is sort of there now. We're almost early adopters of Contour with Gateway API. This is, but Gateway API is GA, and so Contour, this is their first release of Gateway API, but it's now GA. So I would say we do a lot of this stuff ourselves, but do we want to? I don't know. Maybe more flexibility, probably. But
Yeah. If I may add, Contour is also an incubating project, so it has already a larger adoption base, and it has been around for a while, and that was the main reason why we decided on using Contour in the first place.
There's actually a good comparison chart in the Gateway API spec website that compares different providers for the Gateway API and what features they support currently, and then what's their GA status and stuff. And we pretty much gave that a bit of a glance and saw that Contour seems to be the best option for us.
Yeah, and I would say the Gateway API implementation with Contour adds a provisioner overlay. The automatic provisioning and scaling configurator, so we're not exposed to configuring Envoy. All the settings are there, but we're controlling them through the Gateway API, which is, I'll admit, it's still new, but where the standard clusters, if we wanted to host our own cluster or something, not having to build all that stuff, but just relying on the Kubernetes APIs is really beneficial for our thoughts. Yeah.
Okay, thanks.
Yeah.
All right. I think yes. One more question, and then we need to close. I guess I don't know. You keep us honest. Yeah. Okay. Good.
He's not standing up yet.
Yeah.
But he will.
Thank you for the talk. One question. So you mentioned Contour can't allow to talk between namespaces. So it is the only then. It sounds like a kind of ingress points basically you create from the rule to allow. Is that the only so if we need to talk, make things to talk these are the different namespaces. Is that the only thing you need to create, or is there more?
No, that's it. So that reference grant is what it's called in the Gateway API spec. Allows the Gateway API resources to talk to a service in a different namespace. You could of course deploy HA proxy and then talk to whatever service you want somewhere else. That's sort of once you're talking to like HA proxy like we are to talk to the VMs, you could point that back at the cluster, I guess, as well, to sort of once you're outside of the Kubernetes API spec, the security rules are your own to enforce.
So we don't need to create a rule to connect outside. So to connect to VM, you don't need any rules.
I mean, if you have any outbound firewall rules on your cloud provider, then of course, but no.
Yeah.
No.
I would argue that that's basically the space for network policies, and it depends also on the implementation of the CNI. So.
Yeah, but yeah, Contour or Gateway API itself, no. That's outside. It's more ingress. Think of it as ingress space.
All right. Any other question? No?
Yeah, we'll be around.
All right, then thank you, and we'll be around. Yes,
Yeah.
thank you.
Let's have a break.
the same
You knew it already. Yeah. We say anything. It's only Greg already knew that the network exists. We have a point.
So, this is my first time presenting here on the full CNCF.
Hey, back row guys!
Yeah, it's my first time presenting here and pretty much anywhere else, so bear with me. My name is Jose Luis, and I'm doing my PhD in Aalto University on cloud security, but that's really broad term. So, kind of today I want to talk about what we have been doing in terms of network security and isolating applications. This is not my work, I'm quite new on this area, but yeah, there's many of my colleagues like Jacobo. He has been speaking on health tech and things, so maybe if you went there, maybe some of the topics are familiar. More or less what I want to cover today is just a bit of Kubernetes key concepts for, I guess here is a venue that the people are going to know even more than me about the topic, but I will give a bit of an introduction, and then what is the state of the art, or what we have reviewed on the network security on Kubernetes, and then how do we isolate apps and the future work. I'm quite excited about this case study. I will tell you in the end about it. So first, Kubernetes. Well, we all know it's a platform to run containers. We have YAML files, and yeah, I will not extend very much about it. Especially, we have also seen like Helm. I'm not going to talk a lot about Helm, but basically, I want to translate more or less what is our situation. So when I started working on this PhD, of course, we are not running workloads like most of you on your companies. So when we want to test what is the security of something, or we find something interesting for research, and then something to try that on. So basically what we are using is Helm charts that we found like in Artifact Hub. They have like hundreds of applications there. So we use that to test our tooling, or to test, okay, can we improve the security of this, or how we can isolate an app. For that we're using Helm. Our work applies just to Kubernetes, even if you are not using Helm. Yeah, you can use the library we are developing, or the results we have applied to Kubernetes, but yeah, just to make it easy for us to test things, we use Helm charts. Well, a brief introduction on the part of the networking model that we have been more interested working on. So basically, as you know, containers are residing in pods. Pretty much containers inside the same pod are sharing the same interface. They can communicate with the loopback interface, and Kubernetes doesn't really, even if you apply network policies, you cannot really change that. And more or less, what you can change in terms of the networking is what happens out of the pod. So all the containers on the pod share the same virtual network interface, and then you have a CNI that is the one kind of connecting the dots. So the general idea, again, is that for the pods, they just communicate, or they know where do we want to communicate with, and is the CNI the one that takes care of, does this communication happen on the same node, or is this in a different node, in a different cluster, or even in a different physical location? That is taken care by you, and let's say from the Kubernetes point of view, you don't need to worry that much about those things. So yeah, pretty much that's it. So when we are thinking about security or security in Kubernetes, is a really broad topic, and this is the Mitre threat matrix. It's developed with Mitre and Microsoft, and yeah, as you can see, there's a lot of things, and they get like updated. More or less, what we have been focused on is on lateral movement, which is maybe not as exciting as privileged escalation or other types of fields on the security, but maybe because not many people have been looking into that, we thought it's good for the research. And yeah, to make it a bit bigger. Inside lateral movement, there are like a lot of areas. We have been more focused on the cluster internal networking. But yeah, it also applies for containers, or more like pure networking attacks like DNS poisoning. So according to this threat matrix, you have like several lateral movement techniques, and more or less you have some of them that apply to containers, others apply to the control plane. However, like the ones that apply to networking, there's actually not a lot of guidelines or information about what it means to be secure in terms of the networking or lateral movement networking. So according to the description of Mitre, you have this, that an attacker that gains access to a single container can use the network to reach others. But okay, given that description, what does that mean to be secure or to isolate the containers? So that's kind of the question we have been asking around. Okay, we know we need to isolate applications, and this is important to prevent this lateral movement, but how do we do that, or how do we know if we are doing it correctly? Just a bit of specifics. The talk doesn't go a lot on the configuration files, but kind of an idea of how Kubernetes manages these pods, service, network policies, and what does it mean to isolate. This is an example of a Nginx pod that is on the left. I think I have pointer, so okay, it's not working. But yeah, on the left you have like the pod. You have a service that applies to the same pod, and then the network policy that applies to both. So basically, how it works for Kubernetes, you have a label for the pod, then the service knows which pods is managing or which rules that you are, which ports that you are allowing the connection and doing the load balancing, which pod applies to based on that selector, and the same with the network policy. So that's how Kubernetes knows, okay, everything that I'm allowing here applies to that pod. Then another thing that will be discussed a bit later is the ports. So you can define the ports on the pod specification, and later that allows you to define like the same for the service and for the network policy. This is already like quite interesting like for us, because according to the documentation, the ports are informative. They are not enforced anyway, so it's pretty much documentation of the application. However, we see that even if they are informative, and apparently Kubernetes doesn't enforce that, this means containers on that pod could open up the other ports, and that's fine. They are pretty much used on the service and the network policy, because most of the time you are not, you have the operators, but maybe they are not really familiar with all the applications they are handling, and yeah, if you have a port there, okay, I know which port this application is exposing. But yeah, but this is already a bit, okay, this could cause issues. And then we also have that, given these three files, you can also have misconfigurations, like plainly things that are wrong, or maybe they don't align. So in this case, if we have the pod that only is exposing one port, why the service is exposing two ports? Is the service wrong, or is like just the pod and is not updated? We have like the same with the network policy. We can have a port allowed on the network policy that is neither the one in the service, neither the one on the pod, and pretty much this is fine for Kubernetes. Like it's not a problem, or you are not going to have any warning or any signal that this is happening. And then I want to ask you the question. So if we are here and we only have the pod and the service, we don't even have the network policy. Do you know which are the intended connections of this application? Because again, yeah, you have one port here, you have two ports here, and if you are now the person that needs to create the network policy, how are you going to write it? What are you going to look, or what do you trust in this case? Besides, of course, checking the application and checking whatever documentation outside the configuration you have. So we thought this is interesting for doing like a paper, and then we started checking, okay, knowing this, what is the state on how the configuration works and how you configure the networking, let's check what other tools related to security they are doing. So we have static analysis tools that basically just check the configuration files. We also check dynamic tools. In this case, they may run the applications, and they will check for misconfigurations there. And even security platforms, basically, yeah, they are not as simple as these applications, but they can monitor all the traffic that is going on, and they can maybe map better what is the intended connectivity on these applications. So after reviewing all of this, we found that there are some misconfigurations. Again, they do like it. All of these apps, this is maybe a good disclaimer, all of these apps do a good job. However, on the field of preventing lateral movement on the cluster networking, this is the only thing they check, lack of network policies, and if the container is attached to the host network, that's all. Which is good to have, like if you don't have network policies, that's like maybe something you want to check, and the report can be useful. And of course, if a container has access to the host network, that's quite critical. However, we don't think that's all you can do, or it's not as useful like if you're a developer to know, okay, I have this check, I have network policies, is it fine? Because in this case, do you know, like, well, in this case, do you know what are the connections happening on your cluster, and if the network policies that you have match what is intended? Or do you know if these network policies are actually correct? We have this mismatch, and Kubernetes doesn't complain. So these tools also don't complain about these things if there is a mismatch between the network policies and what is running. And also what is missing, some of the tools, also another disclaimer, are adding mitigations, but so far they are not helping at least with these problems. So the first project we started working, this is actually done by my group before I joined, so yeah, I will explain the details, but not an expert on this specific project, is basically checking what is the internal cluster network state. Because so far, okay, you have these configuration files, but that's a bit different on what is the actual connectivity. Containers may be opening ports that you are not aware of. So this is basically what are the first project we did. This is results in Kubernetes, which is a project, is open source. You can find it in GitHub. I think it's there. So basically what they did is, with this application, we have the manager, and then how it works is that for each app that you have on the namespace, it's going to attach two containers. One of them is probing, and it's probing like to the rest of the same pods on the same namespace. So basically, you run this for a while, and this is not going to tell you only what traffic is happening, which maybe other tools can monitor the traffic and then tell you, okay, this is the connectivity that is happening, but what is the possible connectivity? Because again, maybe a port is open, you have not, you didn't receive any traffic there yet, but there's a port open that is not on your documentation, on your configuration, or anything. So basically, this is what the tool does. If you want like a kind of as an easy idea, it's more like taking a screenshot of what is the communication that can happen on the cluster at a given moment of time. So of course, if you run it, you can just leave it running and probing, and then if there are ports that are not open in the beginning, but they are open after all the containers are ready and things like that, you are going to capture like more information, but that's what it does. Of the results, there's also like a web page you can just plug in the output of the tool, and you will see this visualization. And the idea with this is that if this is the cluster, and again, a really simple application, just your app, the database, and we also probe for the public DNS and the internet. You are going to see this connectivity, and it's like, okay, maybe this is not the connectivity I want for this application. Maybe I only want one connection to be happening from the app to the database, and I don't want my app to be connecting to the internet. So having this can help first knowing what is happening, and then checking after you apply the network policies if you are on the state that you wanted to. This is a simple application. When you have like service composition, you have many containers. I don't want to imagine what is going on Supermetrics with all of this mess they were showing us. That's for sure more difficult. So maybe the tool is not that helpful, at least on the visualization, because here you see like a lot. But what you can do is just narrow down like for a namespace, or maybe just focusing on one application and then do your kind of running based on each of the apps. So we ran this with 20 of the most popular Helm charts that are available, and some of the things we found, again, well, that the ports were not matching the specification, so what is open, it doesn't match what is on the Helm chart or on the Kubernetes YAML files. But containers are listening on all interfaces, although we didn't focus that much on container security. There's also non-network policies or many connections that don't seem reasonable that were happening, including access to DNS and internet, and maybe some extra, well, something, at least I was not familiar a lot with Kubernetes before I started working here. It is a bit weird, the thing with dynamic ports, because of course your apps may use dynamic ports, but with network policies there, or at least there was not, I didn't check. Kubernetes is updating a lot, but there's not an easy way to allow, okay, this application has dynamic ports, only that those ports should be open, or things like that. So this is more like the results of the analysis. So after having this tool, again, it's public. The paper that summarizes all results is also public. We can capture the internal connectivity. What comes next? So there are like two main areas, and there are projects that we are currently finishing on. One of them is about what we already checked that the tools were only reporting 2 types of misconfigurations, but is that everything that can go wrong? So one of the projects is about checking new misconfigurations that other tools are not reporting. The other is like, we have seen that enforcing and isolating applications is difficult, especially if you have many things. So is it possible to create kind of a minimum layer of isolation without breaking the functionality automatically? That's like the second project we have been working on. So first project, mapping misconfigurations. Again, as a recap, only 2 misconfigurations were being reported in terms of the internal networking. And what we want to do is identify new misconfigurations, study their impact, because maybe we found something that is wrong, but that doesn't mean it's has a security impact. Maybe it's a misconfiguration and that's all. And also investigate how frequently they arise, because we're in the university and we do this analysis on what misconfigurations are possible, but maybe they are just theoretical and normal apps don't have them. So we also did this as part of this project. So some misconfigurations that we found, again, if you remember what can go wrong on these configuration files, first is like a port is open on the container but it's not declared. Or, for example, a container is allocating dynamic ports and there's no way to actually enforce this with the configuration. A port is declared on the container like the opposite, it's declared but it's not open. This is, again, these are new misconfigurations. Not all of them are as critical as others. For example, this is not as critical as having things open that you are not aware of, but still is something that doesn't align to what you have configured. One label collision, which is surprising that other tools are not checking. So the threat scenario, if you want to think, okay, what is the risk of having this label collision? So you have your cluster, you have all your apps, and everything is working well, and then you install a third-party app, and maybe you're not checking all the labels. An attacker, what it could do is put on one of these apps labels that apply the same labels that you are using on your cluster, and then your network policies will allow whatever you are installing to connect with the rest of the cluster. So, I mean, it's a simple idea, but somehow nobody was checking that. So, maybe you want to check that on your clusters. Other misconfigurations, these are the number 6 and number 7 are the ones that were already identified before, and in M5 we check like other similar issues but with the services instead of the bots. So what we did, again, one of the feedbacks we got from our first project is that we were only checking these 20 apps from CNCF, and they said, oh, maybe this is not exactly what companies are running, because we don't have a lot of data, so if you want to collaborate with us, that will be neat. What we did is find data sets of organizations, foundations, and companies that are public, and then we run we try to find these misconfigurations on those datasets. So again, we run it with Bitnami, Wikimedia, some projects from CNCF, charts from the Prometheus community, the European Environmental Agency, and Onsite Cloud, which is a kind of a CDN. In total, we analyzed 287 charts. And surprise, over 90% of the charts have at least one misconfiguration. More than 80% of the charts, or most of those misconfigurations, is that they are not included in network policies. But we also see like ports that are open and are not declared, and in general, 60% of the misconfigurations are not reported by start of the RT tools. And also interesting, even if some charts include network policies, that doesn't mean all the network policies are correct. We also find network policies that have the errors. So again, a really nice surprise. One of the things because we are kind of arguing that some of these misconfigurations could lead to an attack. In this case, we identified one specific attack, and it was on Concourse, so similar to the last talk. This is also reported. The paper is not public yet, but it will be early next year, so is explained there. But basically, that doesn't mean the rest of the applications are okay. We don't have like a lot of expertise on this pen testing or finding like exactly vulnerabilities. So we found one, and yeah, that's all to argue some of the misconfigurations can lead to attacks, but that's it. Yeah, many of the organizations or all of the problems we reported to the organizations have been fixed, so that's kind of part of the contribution. Not everybody is convinced that the misconfigurations are security critical. Some of them are just written as bugs and things like that, but that's all we can do. And then the second project, so we have now a way to kind of make a screenshot of the connectivity. We also found like new misconfigurations. The third project is about how we can mitigate, how we can create these automatic network policies. So basically we are working again with charts because this way we can test with hundreds of applications that are available. And in this case we are applying it first like with a looking into the code, so only based on what is on the configuration on the YAML files. And then the idea will be how to create these policies, just checking that and not running the applications and actually like checking. There are some network policy automation tools that what they do is you install the application that you want to create a network policy, you provide some traffic, and then based on the traffic you can generate the network policy. But this like just switches the problem from creating network policies to have real traffic for the application to generate this. So because we don't have that data, we change the problem into how to create that without any type of traffic, without running the applications. Basically the idea is that we generate the policies using the chart structure. We can see that some charts have dependencies, and we use that to isolate, okay, this dependency can talk within each other, but it shouldn't start other connections. So basically, yeah, from the YAML file, you can parse into different dependencies. We analyze 465 charts to analyze what are the types of dependencies that they usually do, and then generate the policies using these concepts from software engineering. In general, like this is like the technical term, but it's quite simple. In general, like if you have this chart with these dependencies, first you deny by default access between dependencies. You only allow access from the parent to the children, and also then default deny all of the others. The idea here is you can think about how a library works, that you have some public methods, so your program can call the public methods from the library, but that library shouldn't start other calls unless you specify them. The result is that 90% of these applications can add, so again, this is like a best effort approach. We are not claiming we are limiting to the intended connections, but at least if you have applications that don't have a network policy, this creates a baseline. You can tune it, and we also have like a manual approach where you can specify, oh, these two dependencies actually can communicate with each other, so you can do that easily. But at least this gives a minimum layer of security or a best effort of new network policies. We think this is better than starting from scratch or from zero. And again, 90% of the applications can be automatically secure. The ones that don't are the ones that require some connection between the dependencies. We also created a high-level policy language for those ones where you can say, oh, these two dependencies should speak with each other. So in this case, if you have this type of chart and you don't want this connection to happen, what should happen is that the web server can talk with the database that it's a different dependency, then you can just describe it like that. And you don't need to do this. What is going to create a network policies that allow everything on this dependency to connect with the other, and you don't need to worry about the names of the services that are again like a baseline. Yeah, these are we use Kubeson to test the connectivity, and this is the previous connectivity that were allowed before we applied, and this is the connectivity after. So you reduce again significantly the connections that are happening inside the cluster. Kind of a takeaway of our work, at least on this project, there's still room for improvement in terms of lateral movement protection and mitigation. And also, I will not assume third-party applications are hardened, at least in terms of internal networking, even if they have a network policy. And this is also that we learned when we were talking with some of these organizations and maintainers of open source charts, that somehow there is a bit of a misunderstanding or miscommunication on who is supposed to create the network policies and do all of this work. So if you talk with maintainers of open source, they're going to, or at least the ones we talked, they were like, oh no, we give the chart and the person that is using the chart should be the one creating his network policies. When we talk with organizations using open source charts, they say, oh no, the charts are quite well, we trust what they come, we don't do like a lot of extra work. So yeah, there's a bit of a mismatch, and what we have seen is that pretty much it depends on the developers to be sure everything is correct and that the configuration is updated and everything. So there's not that much like enforced by the platform, more about the developers or DevOps people trying to do a good job. Kind of using this idea that we have seen that this starts like kind of for future work. Because we saw some of these questions, in this case, who is responsible for the network policy is a bit unclear, and depending on who you ask, then it's like the Spider-Man kind of blaming to each other. Also, like kind of questions for people that are actually working with Kubernetes and solving these issues. How do you isolate apps? Are you isolating them in a different way? Maybe all of these network policies don't apply to you because you are solving this issue on the cloud provider level, on the VPC, or maybe you have a service mesh and you use network policies provided by them. So of course we work on the university, and having feedback from you guys will be quite useful. That's why we are planning to run this user study. We ask questions like, how do you secure the third-party applications if you do something different from your own applications, or how are you grouping and dividing apps? We have a bit of feedback already. We see people that they use the namespace, people use Helm charts, and kind of a Helm chart that deploys everything like the whole cluster, but again, there's not like a single way to do it, and knowing like what to do will be helpful for us. And one of the questions that we got when we tried to publish this on academic venues is that, are these apps representative? And we think so, but that's also something that you can help us, because so far we don't know how does a cluster look like. That question, we really can't answer that. I guess it will depend. So again, this is the survey that we are running, and based on the results of this survey, we will do like interviews, so we can chat with the people that leave the email, and I think it's explained here on the last, but we'll give a gift voucher if you want to collaborate and help this open research. We are not creating any product, this is just open source and open communications, open science, so we are happy to get your feedback. And kind of a side note before I finish, we have like also a really smart student working as an intern, and he's looking for a company to do a master thesis, kind of on how to secure Kubernetes clusters and everything. So if you are interested, he's quite cool. So ping me. That's all. I don't know if I talk super fast or I'm not checking the timing, but if you have any questions.
So do you create an application to set up the basics network policies for the cluster?
Yeah, that's an application is not published yet, and how it works is we are using this Helm post render. So basically, between you render the template and you deploy it in Kubernetes, you can just add whatever logic you want there, and we are adding the logic of this network policy generation happening there.
Okay.
So this is also like the reason why we do that and not maybe a separate application is that I think it's easy we abstract from whatever you are using to run or what is your setup. You can, if you are using Helm, then you can use our solution.
Is there any EU regulations or anything, how you guys are working with the lawyers in future? Because it's going to be a lot of discussion.
Oh, on the EU regulation, not really. So
because I mean, if you see most of the services and the big guys are going to pitch in, and then you have a lot of legalities. I can see already.
Yeah, not really, because this is.
Is it like companies like Cisco and Juniper, because they are the internet service providers and they are like your biggest routers in the world, like router producing companies. So do you have any consortium or anything like?
like at least for us, because this happenings is internal networking on the cluster, we don't really need to manage that much, I don't know, other regulations, or at least we are not taking into account that. We actually did a check, for example, CS benchmarks and other benchmarks. That's part of the research we did to see.
Because your clustering can also mesh, you mentioned that, mesh technology.
Oh, no, but we are not, at least, that's actually like a question, whatever, if you are solving this issue with another technology like service mesh, then we would like to hear about that. But yeah, at least we are not.
Because I know how fearsome the competition in the internet service provider were in Cisco and GMRI.
Okay.
I'm just looking at the extension, AI comes and Sora, ChatGPT, all this is coming and like, you know.
Oh, actually I forgot about that. We are not using AI, so if you didn't see it, it's because there is no AI. This is probably normal code, let's say.
How was it? So the helmet is not yet released, right? Did I get it correct? The helmet?
Yeah, no, it will be ready, but we have been rejected from these academic venues, and it's been a bit hard. We got already 4 rejections, which doesn't mean the work is not great, but so far I think in the academic world it's been a bit difficult to pitch what is cloud. So, yeah, from there, cloud security is a bigger step, but yeah, we are getting there. We are actually thinking of just releasing the tool because this project has been going on for 1.5 years and it's getting really old to wait for the publication. But thanks for pointing that out.
Just one question. You mentioned post-render with Helm, but that limits the action to Helm install. There is a lot of usage of Helm that has not used the install command, but they use basically the template command. They render, they post-process that, or they even use that with, like we use it with GitOps tools, and some of the GitOps tools, like Argo CD, they reproduce the behavior of Helm without using Helm. So I don't know if you have any thoughts on.
Like, I'm not sure. I would say, without checking, that you can still use the post-render and just save the templates render, like the files, and that will also activate the post-render. But I haven't checked, so fingers crossed. Otherwise, it's a common feature.
So out of curiosity, so how many, like you did all kind of research. So did you find how many component or how many Helm chart has host network through?
Has what, sorry?
Host network.
Oh, we found. We found.
How many? Some number like.
More than 0, which is the surprise. I mean, some apps actually need like host network. I don't remember which
but
one.
But it's still quite dangerous.
Yeah, it is. Yeah. And well, to be fair, like most of the tools that you are running, they actually show you in red if they have colors like host network, because that's actually one of the few things that the tools are getting right. But yeah, there are still apps there that have host network. So
So it was just mandatory to use that host network, or was it just misconfiguration?
I don't know. Our guess is that before, like, you can get things done if you just, my connectivity is broken, I don't know why. If you add this line, like in Stack Overflow, this guy said with this line everything works, and actually, it works, because your pod now has full control of the network. So that may be one of the reasons, I don't know. There are other apps that actually need like host network to properly work, but that's, I would say, a minor amount of that.
So basically, so when you try to install something, we just trust whatever there is. We just have install message. So if you have like that kind of thing, so of course this is up to us as well, like how sensible you should be.
I think in other areas, for example, on container security, usually the containers are more hardened, and you see like a better work, people patch if there is like some vulnerability. So that part I think is better, but on the Helm charts it's a bit, nobody is land like. You can find a lot of things on Artifact Hub.
Muchas gracias, amigo.
Right.
Let's have another 15 to 20 minutes break and then continue with the last talk.
presentation. Yes, and welcome from my behalf also. Very excited to be here. This is one of my favorite topics. I mean the platform engineering. We already have like 2 very great presentations. Both of them have something linked to this also. So the latest one, network security, that's bit related to regulatory and the security. And the first one, there was like concepts that how do you manage the application deployments. So this very nice one. I already had this in the Azure Meetup maybe 2 months back. So if someone was there, so sorry. But this maybe has a like bit different angle to it. So first, me. So I'm Toni. I work at the OP Financial Group. Very much like open source guy. So Linux, FreeBSD, OpenStack, Kubernetes, OpenShift, a lot of technologies. Maybe only little contributions, maybe more like end user. So 7 years of Kubernetes and so on. Mostly always been working with the infrastructure side, like the platforms. And the reason is that maybe I would like to someday work with the like actual value producing things, but the issue is that there's always something to fix in the underneath. So I haven't got there yet. But anyways, there is like the slides are from with OP label, and there is word Azure. Those are giving 2 different contexts. Of course, that was initially in Azure Meetup, but there is also the thing that we as like OP is now transitioning to Azure, and that's why the examples are from the Azure. Anyways, the examples are on the demonstrations is not from OP, that's completely my own, so that I can share it. So you can also test it if you like. And there is no like OP secrets there. Yeah, and personal life, big family, maybe outdoors, not that much free time. And spending all the free time this kind of thing. Yeah. Yeah, but anyways, maybe one small thing regarding Microsoft is that, okay, maybe it was hard to believe that me like working with Azure maybe 2 to 3 years ago, it wouldn't be a thing. But anyways, now I think it is, and especially in the OP context. And the OP is giving a like good context because now we discuss about platform engineering. And why OP? I don't want to promote OP too much because this is like more about tech talk, but it's giving the one critical context here. So I will quickly show number slide. There's the 14,000 employees. So that means that, okay, when I had one introductory talk in Tampere, I maybe said it wrong that we would have something like 5,000 developers. Maybe we have something like 5,000 to 6,000 people working with the IT and then maybe 2,000 developers or so. So that's the scale. And then the Azure part. So we are migrating to Azure. That project started like a year ago. And I work in our cloud container platform engineering team. And that's one part of our Azure story. So of course, there is a lot of other things. So we are using a lot of SaaS services, there are PaaS services. So this container part now I'm describing and the ideas behind, those apply to only some, even like a big part, but some of the things. But anyways, that's the OP context. And next, the thing is, there was that how do you ensure? It's all about the automation, that's my claim. So the only way to achieve the consistency, to achieve the good developer experience or security is the automation. Of course, there's other things there. Then we are all quite familiar what the developer experience means. That means quickness, easy to do things, how do you get it fast feedback and so on. But then the regulatory compliance quickly. So what it means that, for example, when we are working in a bank, it means that there are NIS. That means that, for example, it requires us to encrypt all the traffic. There is the DORA that's a bit different from Agile DORA. That means Digital Operational Resiliency Act. That means that we need to make that all our operations are well produced. There are run books and everything is checked. And the European banking, though, authorities like checking us. But all this is like bringing complexity, but of course this is a good thing for the customers. So we need to like act properly. So us as a platform, it's a challenge, but of course it's a great thing, not only an issue. So let's start from the basics. What is Kubernetes? I think we don't need to stay here because we all know we run containers. But basically the containers is already a basic building block for producing developer experience. So you containerize the application. Then as you run the Azure, one way of like producing good experiences that are good, but pre-made experiences that you pre-generate like namespaces. This enables reusing the infrastructure and configuration. So this enables like the security and compliance and ease of use. And how do you do it? There are a lot of different things to do. You configure namespaces, there's the airbag ingress. You need to create, when you're on the cloud, you need to do the clusters private, not public. There are the Azure things, quotas, network policies, a long list. But the thing is that actually all this just brings more complexity. So if you think of from the developer experience point of view, it could mean that the developers need to think of more, or from the regulatory point of view, it means that you need to manage more and check more, because there are a lot of things to do. So everything to manage, then there is of course, the application part needs to be done properly. If you think about the CNCF ecosystem, there is a lot of different tools to manage, and of course the Azure on top of all this. So how does this like solve the issue? So that's the thing I'm discussing today. And I'm starting from the very basic. So this is not, if we just throw out the tools, it's not solving the issue. So basics, DevOps versus platform engineering. DevOps means like you usually do it in a team, and now platform engineering is more about creating standards, creating guardrails, and now I'm focusing most on the automation and templating parts. And I will quickly run you through like some theoretical demonstration why this makes sense, and then we go through the demo. So quickly, if you build just an like cloud application, you have the AKS up there in the middle. It means that you need to provision a lot of infrastructure there. So there is like gateways, DNS, you have secrets in a key vault, then you have managed identity to access the database, then you have monitoring. You usually put them in a like Terraform, and you put it in a Git repository and put a pipeline. And this is already a like quite good solution, and this is good for like one team. It's a level 1 stuff. Now I pressed somewhere. But as you can imagine, as we already discussed about the scale, so if you start simply scaling this, you add more Git repositories. Every team does it own, so we just duplicate the same. There will be a very quick, we will face some issues, like, okay, what if something changes, you need to change some configuration over all of these. That will be an issue. Database needs to be hardened. Maybe some API changes. So the second level is that you start library sizing, you do it as a library, so you have a platform team, you strip apart like the database provisioning, you take it to the library. It's another Git repository then, and to refer into the pipelines. And you do the same to all the other infrastructure components. It's not like I call this as a library approach. So you provide the platform as a library. There is also small variation of this like platform as a tool. You could create a CLI that does bit similar things. And this is already like quite good because it makes these issues not to disappear, but easier. Because usually when we had this lot of blocks, it makes them hard to change. That leads to inconsistency, and that leads to inconsistency that's like a diagram that's very hard to solve. And also in that case, you need a lot of expertise to manage it. So it already solves like at least 2 of those. But then the OP context. Welcome to the enterprise. It means that you have even more teams. And that means that it's hard to change something. Like imagine that you need to push the library, that all the teams need to start using a library. It means that you cannot change everything at once. And there will be like some legacy system mainframes or something in the behind always. Of course, we are now trying to get rid of them. And you, of course, mentioned SaaS services. So imagine that you have like perfect Terraform pipeline, then you start reusing some SaaS service. How do you integrate that? Okay, this pipeline integrates to some SaaS service. Then, of course, these regulation rules could mean that you can't actually have everything in one pipeline. And it also means that makes it very hard, okay, meaning, well, a lot of teams, I mean that knowledge or competence management get hard because not all the teams know how to configure networking, how to configure something. It means that you need to start centralizing. So in principle, it could mean like that, okay, we have now moved, this is just a theoretical example, we have moved now the networking to centralized. So it could be a reason that someone says, it could be like also a human reason, that people just want to do it like that. All the networking is now in a single block. It means that you cannot like just push by pipelines. And then you can have some like SaaS monitoring service, and then the things need to be pushed there also. So there could be like integrations, or then you want to centralize some of the things. We can try to solve this with the same library approach. So let's add a Git repository here, and then make all the Git repositories to push to the centralized Git repository. This is already like a valid approach, but actually Git is not that good, because Git is not as a good API. It's just the files, and then it's just, for example, the permission management is a binary. You can either commit or not. You cannot say that I can commit to this part. You can commit to everything or not commit at all. So what we basically want is an API. So this was the introductory part to why Kubernetes is great. So you basically, the claim is, if you want to get a good developer experience, the only way is to increase the automation level. And now the Kubernetes is just very great for that, as we know. So my demo is, there are like 3 concepts here. I have like Azure Service Operator, that's similar to Crossplane, that manages the cloud resources. Then I have like my own operator. That's something I see that in big organizations you basically need to, if you want to get the full automation, you need to start somehow codifying, building your own APIs. So you somehow create for example, own operator. And then you have some composition here. In this case, I'm using Helm. I actually tried Crossplane there, but I failed. I didn't fit to the purpose right away. Need to reevaluate that later. So the demo then. So I have here like VS Code running. It's connected to my personal Azure account. So let's check. I should have an AKS cluster that I'm about to use. And I'm already about to start this simply creates the values file for the Helm chart and runs it. I run it now because it will take some 5 minutes to run through. And then I will go through the contents a bit. I need to open there the dash one, and then I will go here. So this is the repository. And what I have here is the same diagram and everything, but I have a chart that is basically, let's include the size here also, that provides the values interface. So you could imagine that this would be the interface for the developers. There is some like Azure specific things we will probably want to hide, but basically in this case the interface would be that you provide the image and then some parameters. There is actually a bit more than I expected. Let's show a better example, because here is the actual one that was used. So it could be, the interface could be quite simple one. And this will then run the whole stack, or provide that one. And here what I have in how does the, for example, Azure operator looks like. It's like CRDs, or the Azure Service Operator. It's like CRD object that runs the, for example, managed identity. This is a bit similar to service account. So this is used or theoretically could be used to access the Postgre, but I didn't actually manage to do it that far because there is a requirement to do something manually. But this would be the identity similar to the service account. Then I have the database, and for example, the database creation with the CRD, it's quite simple. So all this is provisions the database. So if you compare to Terraform, it's even simpler one. And then we have the basic deployment. And then we have one special thing here. This was my own operator. So I created this my own CRD. And this is just to demonstrate in the diagram you had this, that if, for example, the networking would be centralized, how do you then, for example, make a firewall request? So theoretically it could be something like that. So in a Helm chart you would have your own CRD where you define, for example, source and target addresses. This would be the interface for the developers, or you would even hide this from the developers if you want behind some composition. And here I have the operator that does the magic. And what it actually does is that it creates a PR in this other repository. So now here in this other repository, you have a PR that does the change. So this would be like hacky way to hide the complexity behind. So in the first phase, it could be like PR. Then the network team would do some verification, submit the review. Then we could update the status back to the CRD object after the pull. Did I merge it? I was too fast. So then I have the object here. But this is a theoretical study because this doesn't actually do anything. But this would then trigger that pipeline, for example. And let's now check if the application is up. So what I'm checking here is that is this flexible server resource yet ready yet? Not. And then the other one was the managed user assigned identities. That's already ready. And they are visible here in the, or actually the database is not here yet because it's provisioning. Database flexible. So it's not there yet, but then managed identities we should already have. This was the one that I created. This takes something about 5 minutes, so this should be, yeah, it's now there. And now actually the application is, as we know, okay, let's run PE demo. It's still in a crash loop back off because it was missing the database. If we check, actually, is it now starting? Let's do the traditional. And now it should be starting up quite soon. Yeah, now it's connected to database and utilizing Postgres. Maybe we could check that the application actually there. So this was the public address. This was a very simple ChatGPT generated Go application, so nothing fancy. Hello, Meetup. And then it will go to the database. Yay. So now we have the application provisioned using the Helm chart that provisions like the Azure resources and also the integrations. And now we can just run the same as many times as we like. And even this is like, at least to my experience, like provisioning the basic Azure resources, that's not like the simple feat in this kind of environment. Let's check if I have something else in the demo notes. I think the next part could be start deleting, because the deletion is actually if you think traditionally, okay, it's easy to create resources, but then the day 2 operations okay, you delete the application. So this is usually where the IAC code starts struggling. So now we should have the PE demo application deleted. It means that it started deleting, of course, the Azure resources, so the first one is being deleted. But the interesting part is, of course, that also my network configuration was deleted. So now there is the PR to delete the network configuration in the network team repository. Yeah, and as you saw, of course, we had the 2 PRs for the 2 new apps there also. But this concludes the demo. So as we saw, there were like the 3 concepts. So using like cloud provided operators, there are similar for I think all the cloud providers, and then there's the cross-plane. Then you can use the operator pattern to like hide the complexity, so basically creating an API, and then you usually have a composition, and this composition could also be an API. So we could create an like CRD object that hides the Kubernetes resources behind. So why Kubernetes is great? So for such like, we started from as a library, then the claim was that okay, you need to start building, or you need to start building an APIs, or I would say you always build an APIs. Even for example, even like ticket ops is an API, or Teams as a Teams ops, you always need to start like Teams call to get something done, or whatever. There are like other many ways of interacting with the platform team, but all of these are interfaces, maybe not APIs. So anyways, you end up building an APIs, or you would like to build an API. And so Kubernetes is great for that. Of course, it does the containerization quite well, but the extensible API, there is already when you build an API on top of Kubernetes, you already have the database because you have a etcd. You can easily add the schema there. You already have the airbag system, so you can say that only this team can edit that resource in that namespace. Namespacing is basically the tenant structure. And there's also already also the runtime, so if you want to run some operator or API backend, it's already there in the cluster. So it's a great way of building internal APIs. And of course the CNCF ecosystem, so there are other things like crossplane, and there will be more that does the same pattern. Yeah, Kubernetes is great, but how about, I don't know, maybe if some of you may have a longer background, so there could be questions that we have done this already, meaning as platforms. So I just jokingly did the example that even in OP we had previously like JVM based great clustering systems. The developers liked it. You just drop the application there, it works. But the issue with it is that if there's any something needs to be done differently, it's always tickets. And there is no flexibility at all. The other alternative is, of course, try to search for a platform that is already built with all the features you want. But the issue with this is that either one needs to adapt, or either the company or the platform, because none of the platforms is just a single size fit. And as we know, enterprise, there are a lot of different needs. So it won't be a simple thing. Maybe one more twist here is that as we struggling with the switching, I guess, no. So one twist here is that now as you produce APIs, you can use the APIs to produce this internal developer portal. So actually, even in OP, we have an internal developer portal based on Backstage, or based on Backstage. In Tampere, we had one talk regarding that, and maybe we can have more at some point. But anyways, now this API part is great for integrating it here. So that then creates the even better developer experience. Yeah, let's start closing. So my claim was it's all about the automation, and the Kubernetes is just a great way to build the automation. I'm checking if I had anything here. Yeah, I don't know your background, but maybe this was quite clear for, I don't know, if you have been watching all the latest KubeCon platform engineering videos, this was maybe very familiar thing for you. And for example, I liked a lot of this Daniel Bryant's latest talk. He was exactly talking about the same thing. There are also similar things. Last year's GitOps.con had this AWS presentation. And even in some Microsoft conferences, what was it? Maybe the second and fourth one, they are talking about the same thing. So I see that the thing that we are discussing here, building internal APIs, is needed. And it seems that the Kubernetes is a great way for that. But that's all. Do you have any questions?
Do you check in your Terraform state files?
Generally?
Yes.
In your Git repository? I'm thinking that how...
Please say no.
Okay, yeah, short answer no. Yes.
How do you ensure that the state is consistent?
They are stored as an artifacts. So you imagine object storage or something where you store it. Yeah.
Yeah, but that's the versioning that you use. You don't keep it in Git, but you kind of version it under object storage, sort of.
You mean the Terraform state?
Yes.
No. I'm not completely following, so you...
Then we go to the next question.
Yeah, thanks.
At some point, you decommission a network that had been created.
Mm-hmm.
At some point in the demo, you decommission a network.
Yeah.
Did you explicitly state the network that had to be, because the demo, I have to say, was a little bit too rushed. So that's an interesting thing that happens there.
Actually, the demo didn't have a network. I'm struggling with it. Okay, now it's visible there. Usually, how I think, and I think it's that you have multiple layers. So the infrastructure, the networking layer, you often manage that separately. Then you have a platform layer, and then you have application layer. So usually in the application, now I was showing how the application developer works. That's the highest layer where you deploy, and usually there you don't deploy networks.
You approved a PR during the demo.
Oh yeah, that was the network rule. True. Yes.
That network rule, how did it end up there? Who created that PR, and how do you know that that network rule had to be deleted?
That's based on the naming conventions, and yeah. Sorry, I need to beat because I'm using aerospace and it's mixing my.
And you are not using Terraform there, right? It's operator.
Yeah, because this was theoretic demo, so these were only files. But in this case, it would use Terraform, for example, pipeline that's run by Terraform. But how do you track this? The tracking is done in the Kubernetes. So in Kubernetes, you have this object called. Let me see. So the Kubernetes would store the actual master data. So you have these network objects here. And in this object, you have all the data you need. So basically, in this case, this is up to the platform developer. But in this case, I simply use this name. And this name is equal to the file name. Was that the question? So the tracking is done in the Kubernetes database.
Who issues the PR? Who creates the PR?
It was the automation.
The automation detects that that resource is gone.
Yes. Yes.
The third question is, if you're automating things, why do you create a portal?
Sorry, why do you create?
A portal. Why do you create a user interface for developers when you want to...
Yeah, you mean the internal developer portal. I think there are various reasons. Of course, some of the developers like to use UIs. That's first. Second one is actually that they serve a bit different use case. So internal, this developer portal is more for approving. For example, I would like to start a project, and then it could like, there is a cost involved, someone goes and approves. It's a like different workflow. And then when you actually work and do something, then it's more about the APIs. Thank you also. Are we, oh, thanks.
So, yeah, you mentioned about this, now I lost my thought.
Yeah.
Sorry. What I was about to ask. Well, but anyway, yeah, thank you for the talk. I was asking, like, you mentioned about, well, sorry. No, I lost my thought somehow. I'll come back to it.
Okay, thanks.
From my side, just to take, well, you think about that question. But you were talking about the use case of OP. You mentioned about 2,000 developers. You also mentioned that you use Backstage in OP. Backstage is a portal. What is the orchestration that is actually enabling these APIs in an organization as large as OP? Do you even have one, or do you have multiple platforms all connected through the portal? So.
Yeah, I can't completely answer, but let's say multiple. And that's maybe one part we are a bit like struggling with, how to do it properly, yes. So there are like different approaches. Because even there was this PR-based, because you can of course use, for example, Backstage to do this PR. And there are like different variations. But I would see that this approach would be then the orchestrator.
Yeah, but this would be one orchestrator.
Or for one use case, you mean? Yes, true.
And this is probably the follow-up question, not just to you, but to everyone, because there are not a lot of open source orchestrators. Is it Castor or something like that? Then there's obviously the one from Humanitech.
Yeah.
So anyone here, you or anyone else, actually working with a project that is actually conceived as an orchestrator?
Yeah, but also like researching the same topic, so but no answer.
I've only played around, so that's why I'm looking for people who are actually using it.
But it seems that they are like playing with the very same idea. So was it Gratix or what was the name?
Yeah.
That's using the CRD-based approach, and Humanitech is more, was just API-based approach. So
yeah, the previous one we built one similar idea with Crossman.
Yeah.
So, but it didn't really work as a full orchestrator. That's the orchestrator failing.
Yeah. Yes.
It's back.
Yeah, but it seems that you need to like, as we know, there is no like single answer. So it seems at least we are, what I now showed is like a demo what I have been thinking, and we are already applying some of the parts at OP. But as you know, I cannot directly show that what we are doing. But I see that it's like a journey. We need to start small, and we apply the logic in some part and then see how it works. Maybe after a year or two, we can then say if it works.
Yeah, that's probably my last question regarding that. One of the key aspects of this is cost.
Yeah.
You mentioned the challenge. You either change the organization, you change whatever platform out there is already ready to be appropriated. But then there is, well, but if you don't do any of those, which are also expensive, even just building your own, is also expensive. And one of the key aspects that I think most people are missing at the point in which we are with platform engineering adoption is how do we know the cost? And how do we actually make the case for the cost? I know that we often link that to developer productivity, developer experience, happiness, but that is still a hard case. I don't know how you guys are doing it. ROP, what are your ideas about that?
Yeah, I don't have a direct answers because I think we haven't fully had that hard discussion yet. That how much should we invest, like how long, because it will be a long journey. But maybe my personal thinking has been that there is a problem to solve, and if you don't solve it like that, it will be solved in some other way. So the cost will, in any case, come. So we just need to show that okay, here is the struggle and how do we solve it. Yeah.
Now I'm back. Sorry. So basically, yeah, my question could be a little bit out of scope already. So sorry for that. So my question would be, like, deploying is one aspect. Of course, you need to deploy the application. But next step would be diverting the traffic from. Like you are now in the journey from transforming from on-prem to cloud.
Yeah.
So how do you divert traffic? Are you going to use control? So it was just mentioned before in the previous talk. And then the other question would be, how do you handle the data? Like basically, are you going to still use the on-prem database, or are you also? Yeah, you mentioned already about the provisioning database, but how do you migrate the data itself?
Yeah, that's very OP specific. I try to remember what is public. I think there is the API management system. So when you change the applications, then the API management system is used too.
Is it also like a non-SAF in that sense, like no downtime?
Basically, I think we have a few different ways, but as you mentioned, the data is quite critical there. So if it's I'm just throwing out ideas. So if it's a system that just calls backend systems, so some kind of translation layer, then you can run it in both places. But if the data is involved, then I think it needs to be a kind of service break. But I don't know, these just ideas.
Yeah, we are also in the same zone.
Yeah.
Basically. That's why I'm asking, out of curiosity.
Yeah.
Thanks.
So you are providing this interface for developers, but do you fully trust what is there, or do you have some fail-safe, maybe some feedback, so developers know?
Do you mean a product management feedback or in the installation? Yeah, we are actually using a GitOps system to actually deliver the things. So that's where they get the feedback. So, yeah, so basically you can imagine a pipeline that runs and then it's built there. Yeah. So they are currently using something similar now if they do some local changes and they want to test that does the chart change. But actually it shouldn't be that usual use case that you change the chart, because you basically developers do the application management or the development. Did you have some other part there? I missed it. Oh, yeah. Okay.
Offline maybe.
So what was the business drive for this migration project, and how was it decided, and why was it decided that going to Azure is the right thing?
Oh no! Oh no! Yeah. I don't know how to put it properly. I think actually our CIO had a article in the TV if you want to read there, but I don't know. But I try to recall. I think it's just the biggest driver is the modernization, so getting rid of the old system.
And the reasoning for choosing Azure?
What is? I'm just thinking that what is the public one? Yeah, as you know that they are building the Finnish data center that affects.
Does no Google have one already?
But of course, there are various reasons. Yeah. Yes, thank you.
Thank you. Just, I hope it's not too late to say that the door is closed at 6 p.m. and if you go out, you cannot come back, but I guess it's not need to say that now. Yeah.